Okay, let's do 5-4 problem number 40. Okay, start with A. Suppose the two sides of a quadrilateral are parallel and the one diagonal bisects an angle. Does the quadrilateral have to be special in other ways? If so, write a proof. If not, draw a convincing diagram. The convincing diagram that there's nothing special, I guess. Okay, so you start with one set of parallel lines, right? And then whenever you say quadrilateral, not parallelogram, you gotta draw something that doesn't look like parallelogram. Otherwise, your diagram is going to mislead you. So I'm gonna draw something that is trapezoid because you have to deal with one parallel, and then I make sure that it's not isosceles trapezoid, so I don't draw something special and then misread myself. Okay, so I do something like this. And then one diagonal, so let's just maybe make this diagonal. One diagonal bisects one angle. So between these, this is clearly not bisecting. So I'm gonna call this bisecting. So that will be the diagram. Okay, so it's one set of parallel lines and one diagonal. Diagonal is between the two vertices. So there's one diagonal and there's another diagonal right here. Okay, but one diagonal bisecting, so this is not going to bisect here, right? And what's special about this one? So because these are parallel, these angles have to be congruent by alternating angles. So these angles have to be congruent because these are congruent and these are congruent. So that would make these two sides congruent. So for the A, what's special about it? It's a trapezoid. Quad is a trapezoid with one set of consecutive sides congruent. Okay, and the proof would be, if I call it A, B, C, D, we can say that A, B, D is congruent to D, B, C, and angle A, D, so that's a given, right? Actually not given. It's a angle bisector being a given, but this is like a really it's like a roadmap, really shortened, so that's okay. And ADB is congruent to DBC by alternate interior angle theorem, right? So angle ABD is congruent to angle ADB. Okay, so I should write this on the other order, right? So angle DBC is congruent to angle ADB, and by transitive. So AB is congruent to AD by converse of isosceles triangle theorem. Okay, now B. Now it says repeat the A with these conditions. Suppose the two sides are parallel and that one diagonal bisects two angles of the quadrilateral instead of one. One diagonal bisects. So that means that not only it's going to bisect one angle, but this diagonal is going to bisect this one too. So this is not going to work. This diagram is not going to bisect both. You can only bisect one. So let's just draw something similar. So you have one set of parallel lines, right? And then I draw something that looks like a bisector of this angle. So I'm going to make this part is a vertex. But now I want to make this line that makes this angle about the same. So maybe something like that. Okay, so these are congruent and these are congruent. And so maybe just erase this. And repeat the pattern. So we have to say if there's something special about this. So we started with these being parallel, right? And now these are congruent, but this have to be congruent just like this. So that means all four are congruent, right? These all four are congruent. And if you have two angles congruent, these have to be congruent. But also these are congruent and these are shared, so these two triangles are actually congruent. So I didn't draw it quite right. It's more like this, right? Because it's angle, side angle, because all these four angles are congruent, right? So then actually these are congruent, which makes it a rhombus, this one. It is a parallelogram because its opposite sides are congruent, and then four sides are congruent, so it's a rhombus. Actually, if if it's a parallelogram, you have to prove that it's a parallelogram first. But if it's a parallelogram and one diagonal bisects the both at the both vertices, that's enough to make it rhombus, because you can do angle side angle. Because it's already parallel, so these have to be congruent. So if these are bisecting, all these four become congruent, then that's angle side angle to make all four congruent, and that's a rhombus. Okay, so to write this one, let's see, A, B, C, D, and let's call this 1, angle 2, angle 1, 2, 3, and 4. And in terms of the order, we starting with one set of parallel, and then these are bisected, so that's a given. We want to make this a parallelogram first, and then make these congruent to make it a rhombus. So first we have to prove that it's a parallelogram. We already have one set parallel, so we want to make these parallel. And to make these parallel, you have to prove the 1 and 4 are congruent. Then converse of alternate triangle theorem, you can make them parallel. So you start with angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. So let's change this to measure of angle 1 is measure of angle 2. Measure of angle 3 equal to measure of angle 4. It's just easier. You don't have to worry about the orders. And then 3 and 4, no, 3 and 2 are congruent by alternating triangles. Measure of angle 3 equal to measure of angle 2 by alternating triangle theorem. So can I make 1 and 4 congruent? Right, so 1 and 2. So you substitute 3 in here. No, we want the 4 and 1. All right, so you have to make 2 and 4 congruent, and then you have to put that in here. So then measure of angle 2 equal measure of angle 4 by substitution. Then measure of angle 1 equal measure of angle 4 also by substitution. And so AB is parallel to DC by converse of alternate interior angle theorem. So now ABCD is a parallelogram, two sets of parallel lines, right? And then because measure of angle 1 and 3 are congruent, you can say that AB is congruent to AD by converse of isosceles triangle theorem, right? Thus parallelogram ABCD is a rhombus, and two consecutive sides are congruent. Okay, this would make it a rhombus because you've proven that it's parallelogram already. Okay, just proving the two consecutive sides congruent alone is not going to make a rhombus. You have to do parallelogram first and then this.